that maybe held is right, that on a warmer planet you'll have more droughts in desert regions. Well, it would be nice to know about this all over the world, but clearly the sophistication of these studies is much greater in a place like the United States, where we have lots of scientists looking around, than it is in China or even Australia. Now, since we don't have any warmer analogs, the time the climate was warmer than now, you have to go back millions of years. And of course, the ability to reconstruct what climate was like, how fast things changed and so forth, was much, much, much poorer. So we can't learn much from those warm intervals. And during the last million or so years, we don't think there are any intervals that were particularly warmer than now. But there were a number of intervals that were colder than now. The last one was 20,000 years ago, or peaked 20,000 years ago, and it was cold enough to produce big ice caps both in the northern hemisphere and smaller ones in the southern hemisphere. The ones in the southern hemisphere are smaller because there's less landform to form on, but the glaciers in both New Zealand and Chile were far bigger than they are now. And of course in the north, all of Canada and even where we are now is covered by probably more than a kilometer of ice 20,000 years ago. So what does 20,000 years ago have to say about, to talk first about water? Well, first of all, before I do that, it's interesting that CO2 is shown in the red and temperature in Antarctica is shown in the yellow, because they're both measured on deep ice core at the Vostok site in Antarctica, go right pretty much together. And we had, for the last 400,000 years, sort of a sawtooth-like cycle where climate gradually cooled, and during the same period, CO2 gradually fell. And then this sawtooth cycle, there would be a rapid correction back to warm and high CO2, and then you get a repeat. These high peaks, which would be the warm interglacials, are about average about 100,000 years apart. And it's interesting that climate was sort of going back and forth between very nearly the same extremes. So I want to talk about the last of these extremes. So it would be the last yellow low there, or the last CO2 low, occurred about 20,000 years ago. And what we know is that the desert regions in the United States and also in Israel and Australia, we know that the lakes in our western United States were far bigger, and there have been shoreline deposits have been dated by radiocarbon. So in Nevada, there's now 3 small lakes that are remnants of that once large lake, Pyramid Lake, Honey Lake, and Walker Lake. But at the maximum, that lake covered an area that's more than 10 times the area of the present lakes. Over in Utah, the Great Salt Lake and Utah Lake and Sevier Lake were maybe 5 times, the lake that occupied that region was 5 times larger. So it's clear from the record that during these cold times the deserts were wetter. So this is consistent with Helm's idea that if we go to a warmer climate, the deserts are going to get drier. It's a little complicated because the water that comes into these lakes is mainly from the mountains, so there's some orographic effect, but it probably reflects sort of a general wetting of those regions. Now, by contrast, there's a lake in Africa that sits right on the equator. As you see, it's 200 kilometers across, a big lake, Lake Victoria, very famous, one of the sources of the Nile. Under the present climate conditions, about 15% of the water reaching the lake overflows and goes to the Nile. The other 85% evaporates. During the same time that these lakes in the west were so big, this lake was dry. And that's been proven by coring. In the cores, they find a soil horizon. And the lake sediments immediately above the soil horizon date at about 15,000 years ago. So they date at the close of the glaciation. So this lake became wet again after being dry. At the same time, the lakes in our west, which had much more water in them, dropped down toward their present level. They know that horizon is lake-wide into the deepest regions because it's a seismic reflector, so they can make a sound survey and find out exactly where it is, and it's all over the place. So presumably we could have walked across Lake Victoria 15,000 years ago. So it's interesting. This is of course, Lake Victoria needn't typify the whole tropics, but from what we know about these lakes, it's consistent with what Held is saying about what will happen to our planet as we warm it up. Now, the other lesson that I'd like to talk about is something that, in a sense, I discovered, and that is that the Earth's climate system is sort of quantized. The Earth's climate can jump from one state of operation to another. The first real demonstration of this, something nobody had ever dreamed about, was when they started to do ice coring in Greenland, and there's now 4 or 5 sites that show this same record. Unlike Antarctica, which sort of had a much smoother glacial period, during the glacial period in the northern hemisphere, there were millennial changes that were superimposed on the bigger changes that we saw in Antarctica. And that middle stuff where it's jumping back and forth, it's been shown rigorously that those temperature changes from the peaks that are sort of intermediate climate to the cold ones are about 10 degrees centigrade. These were huge changes in Greenland. It's now been found, well, in the same ice core, the amount of dust in the ice is 3 times as great at the very cold times than it is at the intermediate times, and that dust is coming from the Asian desert, so it tells us something about conditions. I think it's storming in the Asian deserts, but it's clear that dust is coming from the isotopic tagging. It also, there are methane changes associated with these. The methane is lower at the colder pit and somewhat higher during the mid-peaks there. And during the glacial period, that methane was mainly coming from the tropics. So this tells us in the same ice core that the conditions in the tropics were drying out during the colder it got. The more dry the tropics were, the less methane, less swamps, less methane being produced. So now we struggled a long time to understand what this was. Well, I should say one more thing. Records now have been found throughout the northern hemisphere and well deep into the tropics to show the same thing. They have records in Brazil, they have records in China, records in the Caribbean Sea, records in the Arabian Sea, of course records in northern Europe that show the same sequence. And there's no doubt that whatever was causing this made very wide imprint. And they're not seen, let's say, below 20 degrees south. So the impacts are in the north and in the tropics. And it appears, since all these records show sharp changes, the sharp changes come at about the times you would expect. All of the dating of the ice flows is much better because you can